We've now seen both the mean and the median as methods of talking about the center of our data, or the location of our data. Where does the data tend to fall? These are both methods of talking about the center, and they can be similar. The mean and the median can be the same, but they don't necessarily have to be, and often they won't exactly be. Now, if we write down some data, so let's just if I have data, there we go. Let's pop it up now. If my data is 1, 3, 7, let me not mess this up, 11 and 13. Okay, if this is my data, the mean is going to be 7, right? If the sum of x divided by n is that's was it 24, 31, 34, 35. 35 divided by 5 is 7, and the median is also 7. Okay, so in this case, the mean is equal to the median. But one thing about mean is that it is pulled, the mean is impacted as we change any of the numbers. So if I all of a sudden make this into 18, then what happens? Well, this actually becomes then, what is that? That's 40 divided by 5. The mean is now 8, and the median has not changed. The median is still 7. So the mean is impacted positively or negatively by changes in any of the numbers, right? I could have changed any of these 5 numbers, and that's going to impact the mean. The median is not impacted unless I alter the kind of the middle value, right? So increasing this largest value to 18 does nothing. Now, if I change the 7 to an 8, all of a sudden the median has changed. Or if I change the 3 to a 12, that will change the median. But for the most part, when specific values are changed, it doesn't always impact the median. So that allows the mean to be different than the median, and it's something we want to keep track of. And there is a tendency. So let me just go back to our initial example. What we have here, it turns out, with the 1, 3, 7, 11, and 13, it's symmetrical data. Okay, it turns out that it's symmetrical around that center value of 7, right? So 7 minus 3 is, 7 minus 4 is 3, and 7 plus 4 is 11. So the data is kind of spread out evenly. And when that's the case, when we have symmetrical data, the mean and the median are going to be equal. So let's expand beyond just the simple, 5 n equals 5 case. But let's think more with a larger data set. If we were to kind of build a frequency or a histogram, right? If I had a histogram and I plotted out all of the numbers, and the data ended up symmetrical. This was supposed to be symmetrical. It's pretty close, right? Symmetrical being, if I kind of cut it in half, the two would fold onto each other. If that's the case, then the mean is going to be right in the middle, and also the median is, right? So again, if it's symmetrical, half the data is below, half the data is above, kind of that middle point. And so this becomes a pretty powerful result, or I should say, later on in the semester, we will play around with some statistical measures that end up being symmetrical by the way that we build them. So we will see a lot of symmetrical data when we start getting into estimating different sample values. So that is one possibility. But remember, when we take values and we either increase them or decrease them, the mean is impacted. Okay, so I'm going to draw another result here, and maybe I can do it on the same. If I start pulling, so imagine, so this is a little let's play around with how we can think about this. So let's say I take some of these data points here and I pull them out. They say maybe this is like an income, and all of a sudden a few people that were already wealthy got some raises. Okay, so these data points are now over here. What's that going to do? Well, that's going to pull the mean more so than the median, right? So that didn't change any of the I didn't really draw that the way I wanted to. That's going to pull. Also didn't do that quite what I was trying to do. There. So now all of a sudden there's more values way out here on the tail. That's going to pull the mean up, right? So the mean is shifting. But if I haven't changed anything in kind of the lower part of the distribution, the median hasn't moved. Remember, if nothing changes around that center value, where half are below and half are above, the median doesn't change. So if I pull the mean, if I pull some of the extreme values in one direction, the mean is going to shift. So in that case, what we've seen is that the mean is now shifted over. The median has stayed the same. So when that happens, and I'll draw it a little cleaner here, we'll tend to get it's no longer a symmetrical distribution now. Hopefully it's evident that the right hand side here is kind of thicker or pulled further to that direction. Let me just try to draw it more cleanly. So things we might talk about is having a long tail, or a thick tail. So there's more stuff in kind of the tail of the distribution or of this histogram. There's more stuff on this tail than there is on this tail. But another way to talk about that, and in this case, let's say the median might be, say, here, and the mean might be way over here. And what we would call that is a skew. The distribution is skewed, and it's positively skewed. So when it's pulled in the kind of the higher direction, we refer to that as a positive skew. And in that case, we'll see the mean being greater than the median. The flip side can happen if we have, or we can have a negative skew, right? So a thicker tail or a more drawn out tail to the negative side or to the lower end. If this is kind of a thicker area than over here, we will have, the median may not, it might not be right at the point, right? Sometimes it's not necessarily going to be right at so right in the middle is going to be the mode, right? The highest value in our histogram is going to be that mode, but that's not always the case. But the median is usually closer to that, and the mean is going to be pulled down, right? So because there's more values on the low end, or they're lower than their counterparts on the high end, that mean is going to be pulled lower. And so this is a negative skew. And so these are different than the symmetrical one we looked at in the first place, where the data is symmetrical. With that symmetry, it would have no skew, or it would be a skew of 0. And we'll actually learn how to calculate an exact measure of this later on in the semester. But for now, just being aware that as we think about larger data sets and displaying them in histograms, we can think about the relative kind of layout of the data, taking into account the mean and the median. And so that's why it's often both reported to, because it gives you a little sense into, okay, what's maybe happening here. If I report to you that, for a class height, the median is 5'6", but the mean is 5'9", that's going to start to give you a feel that there's maybe a few really tall people in the class. Just from that little information, you can start to get a better picture of what actually might be happening. There's some type of a positive skew to the data. So again, we'll learn more about the specifics of skew in future chapters, but for now, just a broad understanding of how skew comes into play when we think about kind of how and where the data falls is helpful.